Okay, fourth graders. Today we're doing Eureka Math, Module 5, Lesson 35. And today what we're going to be doing is we're going to be using pictures and the associative property. We haven't talked about properties in a long time. But we're going to be using the associative property to help us multiply a fraction by a whole number. Now when we talk about the associative property, what word is hidden in that fancy sounding word? Associate. And don't forget, when I associate with people, I hang out with them in a group. Okay? Does that give you a hint about a reminder about what the associative property means? It has to do with something we were talking about in fifth grade too. Parentheses. Okay, we're going to be talking about how we can use parentheses to group or associate different parts of our equation together to help us solve when we have to multiply a fraction by a whole number. Let's take a look at this equation. If I have 4 copies of 3 centimeters, how many centimeters do I have? Everyone? 12 centimeters. Very good. Now, what's the difference between my first equation and my second equation? I added parentheses now. I'm using the associative property. In multiplication and addition, it tells us that if we only are multiplying or only are adding, I can add or move where the parentheses are. I can say that I have 4 times 3, which is 12, and then my units is centimeters. I can also say that I'm making 4 copies of 3 centimeters. So it'd be 3 centimeters plus 3 centimeters plus 3 centimeters plus 3 centimeters, which is 12 centimeters. You can see that in this bottom one, I'm using the parentheses to say I'm making 4 copies of 3 centimeters. In the top example, I'm using parentheses to say I'm doing the multiplication, and then this is the units. It's telling me how many units, what my units are. Okay? So likewise, we can use parentheses like that. When we move the parentheses, we're using the associative property. We use property to help us multiply a fraction by a whole number. Here we're multiplying 5 by 3/4. Do you guys agree? What's the whole number? What's the fraction? Write it down, 5 times 3/4. We can think of this as, in word form, 5 times 3 F-O-U-R-T-H-S, fourths. Write that down too, because that'll help us. So I can think of it as 2 different ways. I can think of it as 5 times, in parentheses, 3/4. If I do that, it's 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. How many fourths is that? 15 fourths. How can I write 15 fourths as a fraction? 15 fourths. Are there any holes hidden in there? How many fourths does it take to make one hole? 4. Okay. So do I have 4 fourths? Yeah. Do I have 8 fourths? Yeah. Do I have 12 fourths? Yeah. Do I have 16 fourths? No. So how many holes do I have? 3. And how many fourths do I have left over? 3 fourths. Very good. So the answer there is 3 3/4. I can also think of this as 5 times 3 with my parentheses, and then my units are fourths. So what's 5 times 3? 15 fourths, which then, of course, is still 15 fourths, which is still 3 3/4. Okay, so you can see that the first way, I want you to also write down that the 5 times 3/4, when I have 3/4 together in the parentheses, it's written as a fraction. But the second way, the 5 times 3 is what's in the numerator, and the fourths tells me what's in the denominator. It tells me the units. Okay? So we have 8 times 2 over 3. Go ahead and write that down. 8 times 2 over 3. Then let's write it out using unit form. This is the same as 8 times 2 thirds. Let's write it out using words. Thirds. Okay. So using the associative property, we can add parentheses. We can think of this as 8 times 2 in parentheses, thirds. Or we can think of it as 8 times, in parentheses, 2 thirds. Using the previous example, I know that written as a fraction, this would be 8 times 2 in the numerator, thirds, and this would be 8 copies of 2 thirds. Right? Do you guys see the difference there? Now that we've used the associative property to group the 8 times 2 in the numerator, and have the thirds be in the denominator, we can solve it. What's 8 times 2? And we still have thirds in the denominator. Now we have an improper fraction, but I know that there are some holes hidden in there. How many holes are there? 5, good. Because we have 15 thirds would equal 5. And if I take out 15 thirds, how much is left? 1/3. So my final answer is 5 1/3. Remember to always box your final answer. Let's first write this in unit form. It's 12 times 3, what? Tenths. And the way I have it written right now, the parentheses are like that, right? Because 3 tenths are together. Do you guys see that? But I want to use the associative property. Instead, I want to group 12 and 3. Because then as a fraction, I can write it as 12 times 3 all over 10. And then I'm ready to solve. What's 12 times 3? 36. Very good. Divided by 10. That's an improper fraction because my numerator, 36, is bigger than my denominator, 10. I know that 10 tenths makes one whole. So I have 10 tenths, 20 tenths, 30 tenths. I don't have 40 tenths. So how many holes do I have in there? 3. And then how many tenths are left over? So my final answer is 3 6 tenths. First, write down what you see. 8 thirds equals 4 times, in parentheses, 2 thirds. And then in parentheses, 4 times 2 thirds. You'll see we're using the associative property here. So if I have 8 thirds, how do I draw that? Well, I have to draw 1/3, right? And then how many of those do I want? 8. Okay, so you draw them out, but I have this cool tool called duplicate. 1, 2, 3, 4, 5, 6, 7, 8. So what I can do is I can duplicate them and line them all up. Unfortunately, when you're working in your notebooks, you guys don't have duplicate. Do you agree that that's 8 thirds? Go ahead and draw yourself 8 thirds. Now it's asking us to prove that that's equal to 4 copies of 2 thirds. So here's 2 thirds. Here's another 2 thirds. Here's another 2 thirds. And here's another 2 thirds. So do you agree that that's 4 copies of 2 thirds? Go ahead and bracket them so you can show that this is equal to 4 copies of 2 thirds. It's also asking us to show that it's equal to 4 times 2 thirds. What is 4 times 2? 8. And we can show here that we have 1, 2, 3, 4, 5, 6, 7, 8 thirds. So using this picture, we can prove that the associative property really is true. We're not saying that just because Miss O says I can associate with whoever I want and it stays the same, because Miss O is really smart, it's true. No, we can see using a picture that it is really true. Okay, does that make sense? Very good.